So in this video we will deal with mesh analysis. Mesh analysis any question lo iste then you need to implement KVL problem. If it is a model analysis then you need to do KCL. So now let us do this. First of all, what is a mesh? So mesh, it is a closed path through which current flows, but it is a closed path through which current flows, but it should not have any other loops inside it again. Should not have any other loops inside it. So if you consider this circuit, this particular thing is a mesh because it is not having any loops, and this is a mesh. This is a mesh. So you're having totally 3 meshes in the given problem. But if you consider this whole circuit, this is not called a mesh because it is having loops in it. It is having inside again loops in the circuit. So this is not called as mesh. But instead, if you are considering one loop each, then it is called a mesh. A loop means it might have it like it has closed paths. And complete circuit cannot be a mesh. So this is the theoretical part required for this particular problem. So now let's see how to deal with this particular question. So this is the circuit we are having. Now what is the step 1 for doing this mesh analysis problem? First we need to assume the direction of current. అంటే డైరెక్షన్ ఆఫ్ కరెంట్ ఎలా అజ్యూమ్ చేసుకోవచ్చు? either it might be in a clockwise direction or it might be in an anti-clockwise direction, or it might be in this direction also, it might be in this direction also. You can assume in any of the directions. So suppose if we are assuming our current in this direction in all the 3 meshes, so I assumed the current in this direction. Now what is the step 2? According to KVL, the sum of potential differences, PD means potential differences, I am writing the shortcut, will be equal to 0. This is the step 2. Now in step 3, if we have observed in the last case, we use it to give sign conventions, but in this mesh analysis problem, don't go for any of the sign conventions. Instead what you'll do is, see, no sign conventions. Instead, assume voltage drop at each and every resistance. So this might make our problem very easy to solve. So now what will happen? Suppose, see, if I am considering this voltage to be positive, then I'll consider all these resistances in the negative way. I'll explain it how. So if suppose now in this case we are considering the voltage as positive, so automatically your resistance will be negative. So your resistance is negative. Now what we are doing? See, while solving this problem, if our current is flowing from negative to positive direction, or from positive to negative, first I'll tell you with this case, if our current is flowing from positive to negative, then we are having voltage rise. In this case it is drop condition. So now according to the circuit we are having, so this will be our positive, negative, right? So according to the circuit, sorry, this is our positive and this is our negative. This is our positive, this is our negative. Okay, so this is the circuit we are having now. Now let's see how to do the mesh analysis. So we are not using any sign conventions. Instead we are assuming our voltage to drop at each and every resistance. Now what will happen? Now we will consider the equation for each and every loop. So first we'll assume this as I1, this current to be I2, and this current in the loop to be I3. Now what will happen? Let's see. So now what we'll do? We will be calculating the mesh analysis using KVL. So now, since our current is flowing from positive to negative, we will start from this direction, from this particular point. So our voltage is 10, and I already told that since we are taking our voltage as positive, then our resistances will be in negative direction. So this will be -4, and for which loop? So KVL on loop 1. So this is loop 1, this is loop 1, this is 2, and this is 3. So on loop 1, what we are doing 10 minus 4 into, what is the current? I1. Done. And this 4 ohms is being shared with I1 and I2. So this 4 ohms also belongs to this I1, also belongs to this I2. So how you will write this? -4 into I1 minus I2. Why can't we write it as I2 minus I1 is, మనం ఏ లూప్కి అయితే చేస్తున్నామో దాన్ని మనం ఫస్ట్ రాసుకుంటాం. సో వీఆర్ కన్సిడరింగ్ ఫర్ లూప్ 1. సో ఇన్ లూప్ 1 వీఆర్ హ్యావింగ్ కరెంట్ యాజ్ I1. సో విల్ టేక్ ఇట్ యాజ్ I1 minus I2. Clear? Now this will be equal to 0. Now if we solve this one, 10 minus 4I1 minus 4I1 plus 4I2 is equal to 0. You will get 10 minus 8I1 plus 4I2 is equal to 0, which is minus 8I1 plus 4I2 is equal to minus 10. So this is equation 1. Now what will happen if we are applying KVL on loop 2? So now we are considering this particular part. We are not having any voltages here. So now what we will do? So we will consider the resistance. Since resistance we are considering it in the negative direction, the current flowing will be -2I2. And then this 4 ohms is used for I2 and I1, but in this case we will consider I2 minus I1. Why? Because we are doing it on loop 2. Loop 2 has a current of I2. So minus I2 minus I1, and then again 2 ohms is used by I2 as well as I3. So we will use it as 2 into I2 minus I3 is equal to 0. If you are solving this particular part, I'll get an equation of minus 8I2 plus 4I1 plus 2I3 is equal to 0. This will be my second equation. Now let's see how to do KVL on loop 3. So now KVL on loop 3. So see, I have 20 volts of this voltage in this particular loop. So I'll consider the voltage as, since now in this direction, in this particular direction, means our current is flowing in this direction, right? And we are having 4 ohms and 2 ohms. In this case 2 ohms is shared by I2 and I3, but since we are doing it for loop 3, we will consider it for 2 into I3 minus I2. And as the current is flowing in this direction, that is positive to negative, we will consider it as negative only. So minus 20, and then minus 2 into I3 minus I2, and then what we are having 4 ohms of resistance which is on loop 3. So minus 4I3 is equal to 0. If I am solving this particular equation, I will get minus 20 minus 2I3 plus 2I2 minus 4I3 is equal to 0, and then minus 6I3 plus 2I2 is equal to 20. So I got the 3 equations. Now I need to solve these 3 equations in order to find I1, I2 and I3 values. So these can be solved using Cramer's rule or system of equations. it might take a long time, so you can find those values using scientific calculator. If we are using scientific calculator, I will get the values as I1 is equal to 1.093, I2 is equal to minus 0.312, and I3 is equal to minus 3.437. In order to get these three values, the equations that you need to consider are, I am rewriting the equations. So your first equation will be minus 8I1 plus 4I2. So in the first equation, we are not having I3 part. So what I'll take it as 0 I3 is equal to minus 10. This will be our first equation. And second equation is 4I1 minus 8I2 plus 2I3 is equal to 0. This is second equation. Third equation will be 0 I1 plus 2I2 minus 6I3 is equal to 20. This is our third equation. Now if we substitute these given values in the scientific calculator, I will get I1 is equal to 0.93, sorry, 1.093. 1.093, I2 is equal to minus 0.312 and I3 is equal to minus 3.437. Fine, I got the values. But if we consider the given circuit, I am showing you the circuit that we are having in this particular question. So, this is the circuit we are having, right? So, let me draw it in a rough manner. So this is the 20 volts and this is the 10 volts. This is current I1, I2, I3, and this is A and B. Here 4 ohms, 2 ohms, 4 ohms, 2 ohms, 4 ohms. So this is the current we have. If we consider I1, we are getting the positive value, means the direction we considered for this loop is correct. But if we take these two loops, the direction we consider is wrong, because instead it should be in this direction. Okay, so we need to find out. So the direction should be this. To know the particular direction, what we did, we are taking each and everything in the same direction. When solving, we'll get to know the directions. And now what we'll do is, we need to find the mesh analysis for this particular AB, which has 2 ohms of resistance. Okay, so now this 2 ohms is shared by I2 and I3, right? If we are checking with I2 and I3 values, so I2 has got minus 0.312 and I3 has minus 3.437. So which is the biggest value? Minus 0.312 is the biggest value. In the negative, in the integers part, minus 0.312 will be the biggest. So this is the largest number. So what you'll do? You'll do I2 minus I3, which means minus 0.312 minus of minus 3.437. Then you'll get minus 0.312 plus 3.437. So your answer will be something like 3.125. So 3.125. For what you are calculating this value 3.125? This is for IAB, means you are calculating it for mesh AB. So this is how you solve problems on mesh analysis using KVL. I hope you understood this. If you are having any doubt, let me know. And if you are unable to get the values of using this in scientific calculator, I'll show you in the next video. Okay, and thank you for watching.